Hi Lee, this is Scott Silva, and hey, I thought the best way to answer your questions was to actually do a video. So I'm going to try that out right now. These are pressure release valves, and they're adjustable pressure release valves, and they are from McMaster and Carr, and the part number is a 48935K35. They're set in half-inch MPT pipe nipples, and they're a full nipple, so they're threaded on both sides and they're welded into the sheet metal. The way I got the hole in the sheet metal was to use a 1-inch it's electrician's knockout, and it made a perfect hole for the nipple to fit into, and I just welded it around. The construction on this, and I'm thinking that you're looking for a welder that basically can use a MIG welder. A MIG is a wire feed welder, and it's probably, I don't know, 10 times as fast as somebody that can run a TIG welder, but that's how I welded this up. The rings, I wanted to kind of focus on these rings because they were key to really bringing this thing up fast. I built the hyperbaric chamber in sections, so these are 2-foot sections, and the rings are an angled ring, and they're available at RJ Sheet Metal. They're 38-inch. You want to call Ray and ask him for these. They're about $40 each. I used 8 of them, and the phone number there is 503-231-7717. Here's what I did with the angled ring before I welded anything. I took the angled ring to the laser cutter. Now the laser cutter guy did 2 things for me. First of all, the outside of both ends have a double set of holes from the original angle ring, and that was because the pressure was distorting the areas between the 2 bolts before I put the additional bolt in. The outside ring that the thickness of the outside ring is a 10 gauge metal, and and this holds 7 pounds pressure, just absolutely no problem whatsoever. If you wanted to go up higher, I would suggest that you use like 1/4 inch. There's still a little bulge in this at 7 psi, and I'm thinking anything higher you might want to go to a thicker steel. This end plate right here, I had a 24 by 24 hole cut out of the center, again by the laser cutter. The drop that came from that I used for my door. So that piece actually was originally there. Let's see. Or was it? I'm not quite sure now. Oh my goodness. It may not have been. Actually, the opening is 24 by 24, and this piece of metal right here is 26 by 26. So it gave me an added inch on each side. There it goes. Yeah, I'm thinking back right now. Anyway, the additional thing that I had the laser cutter do was laser cut out these feet, and I'm not sure we can get a real clear picture of the feet, but the feet are 24 inches long, and they're 3 inches high at the highest end, and it has the same bolt hole pattern as the rings. There's a 2-inch flat bar on the bottom of the little flanges there, and that'll help stabilize it for when it goes on the ground. Now, in addition to the those little feet that come up, I use something similar to that as a jig, so that the rings were welded into the sheet metal, so that the bolt pattern was perfectly straight. So these could be placed anywhere, and they would line up. It's important that this ring line up with this ring, so that the bolt patterns line up when you're assembling it. Now, in addition to that, this plastic right here is, and I talked to the engineer at Acrolite, and the material is called GP, and Daryl is the man I talked with. It is area code 207-490-4344. Now, this is a pretty large window, and we discussed the thickness and all of that stuff, told him what pressures I was running, and this is what he came up with. Now, we're going to go inside in a little bit, but this piece of plastic has a piece of 1/8-inch neoprene under it that seals it to the metal. The little flange here that I built on the outside, it also has a series of little tiny gaskets underneath each screw hole. So the neoprene gasket seals the plastic to the sheet metal, but then the little O-rings seal the hole from going through the steel, if that makes any sense to you. The other thing that you do with the flange ring once you get it also is go to the gasket guy. Now, you're going to have to find a gasket company in your town that will cut gaskets for you. And this is 3/8 neoprene gasket material that I used here. This is 1/8 inch, and I'll show you on the door where I also put another 1/8 inch gasket. Let me see. Yeah. 1/8 inch, 3/16 neoprene gasket. And the thing I wanted to tell you about these flange rings is they are bent beautifully. They have a weld area where they brought the welds together, and each you need a really flat surface to put the welded area on to see if there is any distortion in that weld. I straightened probably 4 out of the 8 rings that I used. All right. So back to this door. The door, I sealed the door in 2 ways. First of all, with this gasket material that seals the door to the inner side, but then I used a piece of 1/8 inch neoprene to seal the inside flange to the metal of this piece right here. So there's no gasket between this outer metal ring and that. I think I used some silicone or something. But the gasket material is needed here, first of all, to squish down through to seal the bolts that I put through the bulkhead, is what that is. Anyway, let's keep going. So here's the inside of the window, and here's the 1/8 inch neoprene gasket for the plastic, and I drilled through the plastic and tapped an 832, and it's 3/4 of an inch long. And boy, that's a pretty good picture. Thanks, me. Okay. I'm just getting in, trying to close the door. So, trying to get back far enough so I can show you the door. The door, I reinforced with a whole bunch of 1 inch by 1/4 flat bar, and the door frame is made out of 1 inch square tubing. The articulating hinge has 2 hinge points to it, and it really makes it great for closing the door, because you only need 1 pressure at any one point. And I put, this is really a little hokey thing, but I put a little piece of tape here that holds a little piece of wood, so when I'm in it by myself, I can just put my foot up against the door and seal it, and that seems to create enough pressure on that side. This little piece is just a little piece of like 1.5 inch PVC, and it's filled with foam. So this is where the air comes in, and it's an air muffler. Alright. So I'm going to open this door. So the inside of the door is another piece of 2 inch flat bar, 2 by 1/4 inch flat bar, and then I put a 1 inch rib on this just to give it a little added support. And the bolts on the outside are drilled and tapped into this flat bar, so it really makes it rigid as far as this bulkhead goes. We're going to try to go outside now. Now, the air pump that I have that pressurizes this tank is a Bullard. There we go. It's a Bullard EDP-10, and it's a free air pump. They use this for respirators and all kinds of things that are people in sandblasting booths and whatever. This has an air cartridge to it for the intake, and then the discharge has a carbon filter, and it's probably about the purest air you can get. I wanted to show you this too. This is the package label of the foam that I use for the door, and this is 7/16 thick. It's 3/4 inch wide. It has a self-adhesive backing to it. It is a closed cell foam. Now, as this gets pressurized, that gasket gets squeezed, and after about 10 times in this, I need to replace that rubber, and it's kind of inexpensive. It's about $7 or so, but it's easy to do. Just pull it off, stick another piece on there. I haven't found a material that's better than this yet, but anyway, I guess that's just part of the having a chamber. This is my oxygen concentrator, and it's a ANDI oxygen concentrator. It's I can show you the little control panel on it here. It's a 20 psi unit, and there's a regulator here with a so you can increase or decrease the discharge from the oxygen concentrator, and this is a little flow meter, so you can see how much oxygen you're getting. Now, I bought that from a lady named Laura, and it's a OG20, and her phone number is 954 479998. So, Lee, I hope that helps you. You can kind of take a look at this and how it was done again. And I hope it gives somebody else an idea of how maybe one can be constructed. And the only other thing that I did do is these are all 7/16 nuts and bolts, and they're inch long. So I used a lot of them, and the hardware store was just real happy every time they showed up because I was buying more bolts from them. Good luck, my friend, and thanks a million. Bye-bye.